it says the standard enthalpy of formation, delta H formation for barium oxide solid is minus 553.5 kilojoules per mole. The standard enthalpy of formation of barium, oh, that's, well, these are some interesting substances. I'm not sure how we would name these. Oh, this is barium peroxide because this contains O2, 2 minus. So this is barium peroxide. This is barium oxide. Just not that that's part of solving the problem, but I always like to work through my nomenclature as I go. Is minus 634.3 kilojoules per mole. Calculate the energy in kilojoules when 31.4 grams of barium peroxide is reacted. So this is actually going to be a two-step problem, meaning the first step is find delta H reaction. And then the second step is going to be do stoichiometry using mole to mole using mole to mole ratios. Okay, and let's see what that means. So to find delta H reaction from delta H formation values is something that we've already done in the lecture outlines and in a previous homework question. But and the process, so this is going to be number one, is going to be write out the equation. Make a little table where you look up, or in this the case, in the problem statement are given the delta HF values in kilojoules per mole. For barium peroxide, it's going to be minus 634.3. For barium oxide, it's going to be minus 553.5. There is no value for oxygen given, so that's one clue that it's 0. However, you have your conversion equation sheet, and if you look for oxygen, O2 is right here, and I would always look up all the values. I guess I just wasn't sure that the barium compounds were on the sheet, and they're not on this sheet. So the oxygen you can look up on this sheet, which is on your conversions and equations. It is 0. Now the find delta H reaction, it's going to be products times coefficients minus reactants times coefficients. That's a delta. Delta H reaction is going to be products times coefficients. And I guess I'll do coefficients times products. We don't have to put in the 0 here. We should add plus 1 times 0, but since that's just 0, now minus reactants times coefficients. And so my coefficient, and now minus 634.3. Very important to be good with your order of operations, with your minus signs, and then, of course, canceling out 2 minus signs to make a positive. If I add this up, I can see that this is going to be a positive. So I guess I'll do it this way. 2 times minus 553.5 then plus 2 times 634.3 and I get 161.6. kilojoules per mole. That is endothermic. It takes energy to do this reaction. Then coming back to my problem statement, it says calculate the energy in kilojoules when 31.4 grams of barium oxide solid is reacted. All right. So now that I have my delta H reaction, I am going to, and I'm going to back up a little bit here because we're going to need a little bit of space. Give me some elbow room to work. So it says 31.4 grams of barium peroxide. I'm going to have to turn that into moles. So need my molar mass here. I don't have barium memorized actually. Barium 137.2 plus 2 oxygens at 16 each. I get 169.2. And I like to go 2 decimal places. I guess I can't because it's only 137.3. Grams of barium peroxide per 1 mole. All right. Now here comes what I might call the tricky part. So this number here is 161.6 kilojoules per mole. And we might now ask the question, per mole of what? And I would say per mole of reactant with a 1 coefficient. Okay, and let me say a little bit more about what I mean by that. When I talk about energy, I often will put, and I did this in the lecture outlines, I will put energy when it's as either a product or a reactant. This energy, 161.6, is endothermic. Endothermic means that heat has to be put into the reaction. Therefore, I can think of heat as a reactant. So if I write this again as 161.6 kilojoules plus 2 barium peroxides goes to 2 barium oxides plus O2. What this reaction actually says is that for every 2 moles of barium peroxide reacted, 161.6 kilojoules of energy are going into the reaction. And so the actual unit conversion factor that I'm going to come up with is 2 moles barium peroxide per every 161.6 kilojoules, which I know it says per mole here, and that's definitely confusing for students, and I'm with you. It took me a while to figure this out. And so whenever there's something that takes a while to figure out, you always need your process for understanding it and using it. My process goes like this. Whenever I get a delta H, I put it into a reaction just like this, and then I write conversion factors from this. And when you do that, you can see that it is 2 moles barium peroxide per 161.6 kilojoules. And that is a relatively advanced topic, meaning to be able to think about this is something that is useful to do, but it is a little tricky. All right. Any questions about that? Okay. So yes, even though the delta H reaction is 161.6 per mole, kilojoules per mole, it does take 2 moles based on the reaction that we're given. Then, we're done because we're looking for units, calculate the energy in kilojoules. I've got units of kilojoules. Ooh, surprised myself a little bit there. Sometimes I finish the problem before I even know it. But my units tell me, and they always do. My moles of barium peroxide cancel, my grams of barium peroxide cancel. Let's multiply this out. I get 31.4 divided by 169.2 times 161.6 divided by 2 is 14.99, or to 3 sig figs, 15.0 kilojoules. And our units are kilojoules because our per mole cancels out. That's how you know this is a heat. And it says way up here, calculate the energy in kilojoules. So this problem statement also has the units correct. And now what I've been doing is, after I work the problems, I've been punching the answers into Blackboard just to make sure that Blackboard agrees. And so far, everything has been good.